Hello and welcome to MakeCode Live. It's me, John Park, and here I am inside of the MakeCode and coming to you. If you are joining us over on Twitch, hello. I'm going to keep a little bit of an eye on the Twitch stream, but if you're looking to chat, then I recommend you head on over to Discord. The Adafruit Discord is at adafru.it/discord, and that's where you'll find the big chat happening. Also keep an eye over on YouTube, but I've only got so many eyes, so you know how that goes. Let's see. What we've got today is a project I'm going to be working on and showing you inside of MakeCode for Microbit. You can see I'm rearranging stuff a little bit here. And what I'm going to show today, I have a few cool little tips and tricks and things that I think you can apply to any project. But inside of the context of using the microbit as a music instrument controller. We're going to use it to send notes, MIDI notes. If you're not familiar with MIDI, it's still after, gosh, this was started back in 1983, but still today, MIDI is pretty much the predominant method of sending information, data between different musical instruments and controllers, electronic instruments and controllers, and computers as well. And it comes in a bunch of different forms, but the method we're going to use with the microbit is a little different than some I've used before. We're going to be sending MIDI information using, here I'll pop down to a down shooter here for a second, and you can see, here's my little microbit. I'm going to have the microbit connected over USB, and it's going to be sending serial data, messages over USB to my computer, this very computer right here that I'm using. And then I have a little bit of extra software that's going to bridge that serial data that comes from the microbit over to some software that I'm going to use. And I'll use the free, it comes with your, if you have a Macintosh computer, I'm going to use GarageBand. But there are plenty of free synthesizer apps and software out there for different operating systems, some that even just run inside of a web browser. If you're using a web USB or a web MIDI capable browser such as Chrome, there are some pretty cool synthesizers you can use there that you can control with a MIDI controller. Now, when you think about a MIDI controller, often you'll think about this sort of thing, a little keyboard that has a bunch of knobs and buttons and pads and things on it. And this will work pretty much the same way. It's sending the same information. And it's going to be interpreted the same exact way when it lands in your software on the other end, in your software synth. And that's one of the reasons that I really like these MIDI projects, is that we can use all kinds of little controllers like a Feather or a Clue or the Circuit Playground Express to send MIDI data. But today I'm going to use the microbit, and one of the reasons for this is that there is a really convenient microbit extension. Oh, gotta check my audio level. For some reason my audio level is low. Sorry about that. Let's bring that up. How about that? I'm hoping that's better. Thanks, C. Grover over in our Discord chat for mentioning it. I think my audio level's low. I'm also not super close to my mic, so I'm just gonna move that in a little bit there. And just let me know if that starts peaking, because that's my other problem, is then I get too loud. In MakeCode, so far, as far as I know, only the microbit and the calliope, I think, those may be the only two boards, controllers, microcontroller boards in MakeCode that have the MIDI extension that Microsoft wrote available. There may be third-party ones that work on others, but I haven't used them before. And in fact, there are actually, I think, two flavors of MIDI extension for the microbit that you can use. And one of them is the one I'll use today, which is over your USB cable using serial data. And there's also a version that works over Bluetooth. There's a BLE MIDI And I'm not sure if that's real BLE MIDI, or if it's most of the projects I've seen using it send between 2 microbits, and one is hardwired to the receiving synthesizer. So I'm going to use this this sort of standard, almost old-fashioned, but in a good way, wired serial data type of controller here today. And I'm just going to check back in real quick. Okay, better level on the audio and no clipping. That's a good sign. I'll dare to turn up my gain just a little bit, and hopefully that stays good. So let's get, first of all, a feel for what it means to be sending MIDI data from the controller. So this is also a grand experiment for me because I haven't tested. Hopefully we won't get an echo, because I'm going to be playing audio through this. This is GarageBand, and let's look at it this way. Okay, so here's my microbit, and I'm going to be checking a console here too, and I'll explain what all this is about in a moment. But I'm making sure that my serial data coming off of the microbit is going to be routed into general MIDI use on the computer. And now GarageBand here just pretty much looks for any MIDI controller you plug in. I could plug in that controller that I just showed you, and it would start working pretty much immediately. So now what's going to happen, I'm going to turn up the volume a little on my computer, and hopefully we won't get an echo. Hopefully we'll hear something. Let's see. Okay, so you should have. I heard it, and hopefully you did too. Oh, let me turn down that. I've got a headphone volume that I was hearing. So I'm going to try that again, if you'll listen. Oh, now I've broken it. Let's see. Did I turn down the wrong thing? Okay, 1 second. And let me just check that serial data again. I might have messed with it. Yeah, I sure did. All right. Okay, so here, listen carefully. Okay, so I'm playing a little melody, and it is heading from the microbit to the computer, and that's when I press the A button. It sends this little pattern with some rests in there as well. And it lands in this GarageBand here. And right now it's playing this, these are all software synthesizers, so I could pick a different one. How about this little micro pulse one I like? Let me pick that. And let's also, let me check. Yeah, there we go. I'm going to switch over to this massive saws. Ready? And you let me know, actually, I'm going to check the Discord chat. You let me know if that's not loud enough to hear. Board sound is very low. Okay, yeah, so I'm just going to simply move my mic over there while I give you a little playback demo for a second. Okay, and hopefully that's loud enough that you can hear what's going on. So the MIDI data doesn't have anything to do with the actual sound of the effect that we're hearing or the character of the instrument. So all it's sending is note information, almost like sheet music. So you can, in this case, think of it as a simplified version of some sheet music that's just telling us some notes to play and their duration, so the pitch and duration. That's really all I'm sending right now. And I say right now because we can send more than that. But right now I'm just sending this little simple sound, little melody. And what I've done is I've also set up the B button here to send out a chord. So it's going to play 3 notes at once, and you'll hear that. I'm going to move that mic again when I do that so that hopefully you can hear that pretty well. And I'm going to do that one more time, but with a different synth. And some of these have a really long decay, which means they'll play or almost sustain that sound for as long as we want. I got to figure out which one does that. I can't remember. Let's see. It might be this one. Okay, so you can see there that I actually set this one up so when I press the B button, it plays the chord and it holds it. It's as if you've got your fingers on the keys. It's going to hold that as long as we want. It'll sustain it for as long as we want until we press it a second time, and then it turns off those notes. And if we take a look actually at the code that I'm using, so let's now finally get over to the MakeCode session. Let me hide my GarageBand there. So I'm gonna go ahead and hide the simulator. So we'll just be looking at the code and the categories here. And I just a second ago I said something pretty important as far as how MIDI works. I said that I'm sending a note on information for that chord. I'm sending a MIDI message that says play these three notes. Maybe it's C, E, and G. And only in this case, when I press that button a second time, does it send a note off piece of data or message. So the messages are broken up into note on and note off, and there are variations on how that's done. But in the simplest form of that, it will send the note on message, and until it hears otherwise, it's just going to keep playing that note. And depending on the type of software synth that we've picked on the other end, you may not actually hear that whole time if it doesn't have a long sustain, or you may, like that last example, it kind of swells and then it holds, and it's going to it'll hold all day until I press that second button, and then it gets the note off message, and then it finally releases sort of a virtual sustain pedal, or like taking your hands off the keys. Okay, so with that in mind, I'm going to talk about how the setup works here. So first of all, inside of MakeCode, and I'm going to put on my glasses here so I can read this well. Inside of MakeCode, I'm going to initially have to click on extensions down here at the bottom. And so if I click on that, I can then add different extensions to the main code that's available. And in this case, what you'll do is just type in the word MIDI, M-I-D-I. It stands for Musical Instrument Digital Interface. So I'm going to type in MIDI. And when I hit return, I'll see two options show up. Remember I mentioned there's regular MIDI, that's what I'm using, connected with a wire. And then there's this Bluetooth MIDI, which uses the radio, the Bluetooth radio. So we're using the sort of default classic MIDI here. So I click on this, which I've already done, so I won't do it a second time now. But once you've clicked on that, a new category will appear in your categories list on the left here, and it says MIDI right there, has a little music note in front of it. And interestingly, you'll actually use this in concert with, pardon the pun, the music blocks, which already exist by default. So typically, if you use the music blocks, you're just going to play sort of little bleepy sounds over the tiny speaker that's built onto the board. And it's definitely fun and interesting, but it's also not the most musical sounding. Just the timbre of the sound itself and the volume of it doesn't really compare to plugging into your computer and using a software synth. But we will still use some things in here, such as the tempo, which is this block here for beats per minute. I'll use that just to set the tempo of a particular passage or a song, and that can be changed. So something like 120 beats per minute, that's a pretty typical tempo that you'll set something to. In fact, there's this set tempo 120 block, that's the default there. And we'll also use rests in here. So rest block allows you to just do nothing, pause. It's similar to using a pause block. Excuse me, I gotta wipe these glasses. Filthy. And the nice thing about the rest blocks is instead of working in milliseconds, we work in music note intervals. So things like a quarter note, a half note, an eighth note, a whole note, those are all convenient to work with when we're talking about musical notes. So we will use some of those music blocks. That's much better. But if I head down to MIDI here, we'll take a look. In fact, I'm going to zoom up my interface a little bit so that those blocks are bigger. So let's look at what we have here. First of all, there's this initial play section. These are interesting because they kind of marry the two worlds of the music types of blocks and MIDI. And the reason I say that is if I look at this MIDI play tone C for one beat block, let's bring that in here. Zoom that way up. The way this one works is that it allows you to pick a musical note using this little keyboard. And I think I might have the little sound speaker turned off. No, it's on, but we're not hearing it. That's okay. But when you're working with this, you can kind of preview your sounds by picking on this keyboard, and it'll play a little tone. And you can set the duration. So like I said, here's a whole step, or 1 beat, half, quarter, eighth, 16th, 2 holes, or 4 holes, whole notes. And what this block does is it does a conversion under the hood that says if you're trying to play a high C, for example, where'd that high C go? High C is 523 hertz, or 523 vibrations per second of a wave. If we pick this C, high C at 523 hertz, what's happening underneath the hood is that the MIDI extension that we added will correlate that to a MIDI note. What does this mean? Well, if we look at MIDI blocks again, and I'm going to scroll down a bit to this block here under channels, which has this mysterious this note. Let me put it up here at 69, which is a MIDI note number for a duration of 1 beat. That may actually be, let's look over at a cheat sheet. That may actually be the correlation between that C. Is it? No, it's not. It's an A. Okay, so 69, note 69 is an A. For a high C, I think that's going to be 72. So what we're seeing here are different octaves, and each octave has a set of 12 tones in it for Western music, and those are represented by 12 MIDI notes. And so those start at 0 and they end at 127. So that's the full range of notes that you can express over MIDI. It's a lot of notes, more than a piano, which is usually 88 keys. So the reason I show you that is that a high C is, if I have this right, it's either 72 or 60, but I think it's the 72. And so if I set this block here to a 72, these would do essentially the same thing. I'm not showing some of the mechanism of what this business is right here. Why is this variable here? We'll talk about that in a minute. But these are essentially doing the same thing. And so if you start to do things in the MIDI world a lot, you get used to these note numbers, and these will make sense to use these note numbers. If you're using either this little virtual piano here, or note names, or frequencies, then this will make more sense. But in the end, these will both send the same MIDI message. So if I bring in my little debugger here, this is a terminal window or a command line interface. If we look at, let me get that off of my face for a second here. There we go, that's a little better. If we look at what happens here, this is when I'll go ahead and play that little melody again. So you'll see for every note that was played, pressed, and released, we get a message. So that's 2 messages per note. To be played, there's a message, and to be released, there's a message. And what this debugger is showing me is that there's a message for sending a note on, which is this 144, and sending the note off, or lifting the finger off of the key, which is this 128. And here is that note number. So remember I said, I think, was it 72 is the high C. So these are in the mid-range here, but these are all notes. Looking back at this chart here, we can see some of those notes there. So I'm working with these, this octave here and this octave here. And then the last bit that you saw here, this 127, this is the velocity. So a lot of MIDI controllers allow you to press lightly, medium, hard, and it can actually tell ideally 128 variations of how hard you press. In practice, it sometimes isn't that much. But a 127 is the full velocity, so it gives it more oomph, and that can be interpreted a lot of different ways. But in this case, it'll be sort of a loudness. How loud did we play the note? So getting back now to the MIDI category of blocks here. So I said we've got this play. We're going to ignore this drum stuff, actually. Whoops, I didn't mean to bring that in. We'll ignore that for now. Here is, remember I said that we're really always sending a MIDI note on and a MIDI note off. So these two blocks are a little more honest about what happens under the hood. This one just is convenient because it wraps up an on, a pause, and an off for you all in a single block. So those are really nice. But to break it down to its elements, it's really going to be a tone on or a note on and a note off with some pause in between. A MIDI pitch bend allows you to do like it says, vary the pitch. So you'll hear on a MIDI keyboard, there's often a wheel on the side or sometimes a joystick, and allows you to usually pitch up an octave or a whole step rather, and down a whole step, or maybe 2 and 2. So you can hold a note and just hear it come up and down in pitch. So that's a block that we can use. I'm going to ignore these constants for a second. And now these ones here, we brought one of these out before. Remember I said these are a little more about what a direct translation of how MIDI works. And so we have things like the note on and the note off, and we can specify the note number. Here's the set velocity. So if I want to change the velocity of a particular key press or a section of them, I can use that. Here's the pitch bend. This is this set instrument, which allows us to pick different patches or presets. And then there are some other, these are pretty advanced. It's common stuff you find in all MIDI things, but a lot of it's really necessary. Things like turning all sounds off, changing knobs and dials with a thing called control change or CC. Being able to change the aftertouch, what happens when you lift off. Is there some secondary sound that happens when you release? And then we have at the bottom here, these are actually one of the first ones we're going to use in the program, which is how are we sending this data? So we're going to end up sending raw MIDI serial data. Oops, hold on one second. Hey, that was nice. You just got a good glimpse into a weird message stream, so enjoy that later if you pause on it. I was trying to bring up Discord. There we are. Sounds like, oh good, yeah, sounds like setting the speaker next to the microphone next to the speaker helped a lot. Thank you. And so let's get this set up. So if I look at my scene here, I'll get rid of these extra blocks. First we'll go to startup. So on start, I'll move this a little bit out of the way here. Okay. So I can actually put this one first, this use raw serial. And that's what is going to define things like the transmission speed and the parity and start and stop bits. So these are all communication protocols settings that allow a device or a piece of software to receive the MIDI message and know what to do with it, to be able to say, oh, that was one 7-bit message that meant press the middle C, and so on. So we will set this use raw serial. That one works well. Then I said that there's some setup that's required. So if you you can actually just Google this or search this on the internet, microbit MIDI, and you'll find very quickly some articles on setup. And what they usually require you to do is create a serial to USB MIDI transport layer, and so or helper. So there's a piece of software called Hairless MIDI that was very popular for this. It does not work on the current version of the operating system I'm on. It doesn't work on Catalina, but it worked on previous Mac OS, and it may work on Windows and Linux. So that's a typical one. It has a nice graphical interface, and it just says we're going to bring in things that are coming over whatever TTY port that the microbit is plugged into, and we're going to send all that data over to look like a USB MIDI device that's plugged in. I'm doing a similar thing with a piece of software. It's what I keep showing over here in this window here. If I, let's see if I can quit that for a second. It's called Serial MIDI. It's a Python script that I found online, and it's got a nice README. It tells you how to set it up. This is what the command I'm sending looks like. So I'm using, I'm specifying in Python 3. Let me make this wide. That's about as wide as I can go. Make it all the way wide, then it'll read like one line. So that's what it looks like. It's similar if you've done open serial ports up on any microcontroller, particularly on CircuitPython. We use this a lot. It's what's going on under the hood in Mu with CircuitPython. But here I'm saying run this program with whatever device is plugged in. So it looks like a USB modem to it. That's my microbit. This is the speed it's being sent at. It's actually 115200. And then the name of the in and out buses are something that's happening on the system level. So if I look at this is part of the operating system audio MIDI setup, and in MIDI Studio I have an ISC driver that has this, bring this over for you, has this little setup that takes this port in, and those are the named ports that I'll be using in any application. Let's apply that, minimize that, and then if I look at a piece of software like MIDI Monitor, and there's lots of these free pieces of software that will show you what's happening on MIDI ports. You can see here, I should be able to, let's run this. Once I run this over in my MIDI Monitor software, we should get, here, I'm gonna relaunch MIDI Monitor so it shows us that source. Oh, it's not showing up. All right, we'll ignore that because I don't want to break things. But that should be showing up in there as a MIDI source, and you can hear it's still showing up to my software synthesizer as a source. Okay, so I know this is a lot of explanation, but I think it's nice to understand what's happening under the hood a little, and then you can really play. So let's really play. So what I'm doing when I set up, first of all, you'll see I've got this use raw serial. Then I've also got, I'll rearrange these, I've got this set tempo, and remember I pulled that just out of the normal music category, so I can say what tempo this song is playing at. And then I am calling some functions that I created, and that's just to neaten up my code. These could happen right here, but I decided to break them off into their own so that they're a little easier to understand. So let's first take a look at define notes. Remember this chart. So this chart shows me that a C2, and sometimes this convention is off by an octave, and this would be called a C3. But I think a C2, the way I'm using it, is a 48. And a C sharp is a 49, and a D is a 50. So I want to create a version of that right inside of MakeCode. So this function that I have that's called define notes, if I open this up, you can see here I've got A sharp, B, C, C sharp, D, and so on. And I've defined 2 octaves worth. So I've got actually A2 through G sharp 2, and then A3 up through A4. So got an extra note on the end there. So what this is simply an array. If I look down in the MakeCode arrays over in the advanced categories, I can create a text list. So that's what I started with. So I started with a text list, and I just simply added to it until I had enough space to type in these note names. And since these are text, I'm going to be able to refer to these a little more neatly if I look at a piece of music, or if I look at a tab chart for like a guitar tab chart or a set of chords. This is nice because it means I can enter in the song just as letter names, which is a lot easier for me at least than trying to keep track of MIDI note names. But in order for the program to work, it does need that correlation between sort of human readable names and MIDI note numbers. So what I've got is a second array. This one is a list of numbers. So again, over in arrays, under list, this is a number list, and this one is a text list, or yeah, so strings can be here, integers can be here for our purposes. And so I've got this list of whole numbers. 45 is the first number, and that correlates to our A2, looking at this chart again. So A2, what did I say it was? 57? Is that what we started on? Let's see. No, 45. Okay, so it's off by the octave, like I was saying it can be. So 45. That's where we're starting. So that's the 2. Ignore this octave 1. This is one of those battles that's never going to be won, and we have to live with both. So those numbers then just go up, and each number represents a half step. So every MIDI note number is a half step or semitone. And I have exactly the same number of these in this list as I do in this list. So the question then becomes, how are we going to refer to one of these and then have the software figure out that we mean one of these? So notice that I said these are all in order. So if I use any code that says, hey, tell me which number in the list, or which index. So this is index 0. That's the first thing in this list. It starts at 0. This is the second thing. So this is a 1. So 0, 1, 2. So if we ever ask for a B2, we need code that will say which index in this array, the note name list as I called it, is the B2. So we're going to have it look through, and it's going to give us back an answer. There's actually one really convenient block that does this for us. I'll show you in a second. And it will say, okay, in the note name list, if you're asking for a B2, that is index item 2. So 0, 1, 2. Then I'm going to have a piece of code that says, okay, retrieve for me from this other list whatever number lives in that third slot, or item 2. So 0, 1, 2, and it's a 47. So 47 is the MIDI note number for the B2. And again, we can confirm that on our little MIDI chart here. A B2 is 47. Yeah? Hope I got that right. Yes, it's 47. So that is one of the first things we're doing in this software, is just simply preparing these two lists so that we can refer to things by number. So let me minimize this define notes. And now what I'm doing is I'm calling in and defining a couple of songs. Actually, I have two on here. I've just been playing the one little melody. So define song A. Let's see what happens there. Define song A. This is simply another text list, and I've set in here a little pattern of notes, C, E, F, A, C, 2 rests, a rest, and an A that's up an octave. And then for convenience for myself, I've also created a thing that's the song length, which is generated for us. So if I go and add a note to this, I don't need to update things in a whole bunch of places. Instead, I just tell this variable that I made called song A length to find out the length of this array. So this is a block that can just say how many items are in that list. And I want to get one item less than that so that we stop on the final note and don't go one beyond, again, because of the way the indexing works. Since we start things on 0, if this is, let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 items, I'm going to actually stop things on 9 because those things will always start on 0. So 0 to 9 will be 10 items. So this is how the song is defined. And then the other setup that we're doing is I'm creating a variable that I'm calling lead keys. This could be synth, this could be grand piano, whatever you want to name the instrument that you're playing. and tell it which MIDI channel it's happening on. So in order for a lot of items to coexist, MIDI can have 16 different channels. So that could be plugged into 16 different synthesizers, for example. And so I'm going to use MIDI channel 1, which is a pretty typical standard channel to use. And then for something we'll use later, we'll ignore this for now. This is a little switch that we can flip. So then what we're going to do is we're going to take a look at what happens when I try to play a note. So the way I'm playing, or rather one of these songs, so the way I'm playing these is with my buttons. So remember, if I press a button, let's hear some stuff. We haven't heard some stuff in a while. Okay, so that was that little song that we just looked at. Bum, bum. And if I look at what happens when we're pressing A, here's what it's going to do. We'll iterate through from 0 to whatever that song length number was. Remember, that was our actual length of the array minus 1. So this will go from 0 to 9 for this song that has 10 notes in it. What we're going to do is we're going to use a little bit of a comparison logic to look and see when we retrieve one of those note names. So I think we said that let me bring that song definition over here so we can look at both. So when we run through this the first time, so index is a variable that starts out at 0, and each time we go through this loop, it's going to add 1. So on the first time through, it will say if the song A lists value at 0 in this case, so that's this, C2, if that value, that string or that character or text that we're seeing, if it's not an R, and that's because I decided to use an R to stand for arrest. It's fairly simplistic. It's whatever I'm kind of making everything be a half beat here in this case. So if we see arrest, if we don't see the letter R, then that means that we're going to proceed. If we do see a R, we'll jump down here and we'll just rest for that one cycle through of seeing an R. But this first time through, the value we get is this C2. And so what happens in that case is this is proven to be true. The value is not an R. So we go ahead with this next block. And this block is a function that I created called convert note to MIDI number. And the argument that we're feeding it when we run this is whatever that value was. So the song A list get value at index is C2 this first time through. So we're going to say convert note to MIDI number C2. So that's what we're feeding it. So what does that function do? Let's go and have a look at this. Convert note to MIDI number. And I'm going to open up my note definition too and bring this down here so we can look at all that. Okay, so we've just called this convert note to MIDI number, this function, and we're saying the argument to it is the C2, the piece of text called C2. So it all happens in these two blocks. First, we're going to set a variable called note index. This is me finding out which number in which slot that's in the list. So I'm going to create this variable called note index, and I'm going to set its value to be the note name list find index of note. So remember I said there's a really cool block. Here it is. If I look over in arrays, I think is it down at the bottom? Yeah, operations, list find index of. This is a really cool block. This thing is doing a whole bunch of comparisons, and it's saying, I'm looking at every little slot in this definition list until I find one that has a C2. And when I do, I'm going to remember its index number. So here it'll look through and it'll say, is this a C2 at index 0? No. Is this a C2 at index 1? No. Index 2? No. Index 3? Yes. So index 3 is the answer to what this variable gets set to. So now that set note index variable equals 3, the next thing happens, which is we're going to set a variable called MIDI note to be whatever that note list's value is at 3. So scroll down to that note list and look for item 3, 0, 1, 2, 3. It's a 48. So that means that if we go back to what happens when we press the button, we've now gotten a variable called MIDI note to be, I forget what I said now, 48. So now we're going to use this MIDI block here. It was this MIDI, this note duration. So we're going to send to MIDI channel 1, that's what this lead key stands for, the note 48, is that what I said? Yep, the note number 48, and it's going to have a duration of a half a beat. Shoo! So that's what gets sent over serial, and then it will repeat this for every item in that song list. So it's going to send the MIDI note numbers for C, E, F, A, C. It's going to hit a rest, so it jumps down here and it just does a rest. It hits another rest, does it again, and then an A, a rest, and a higher A. So if we go ahead and play that now, let's pop back down to our down shooter, and we'll actually open up the view to look at GarageBand here. And you know what? I'm also going to pop open this little guy here so we can see those messages come through. So remember that first note that gets played is a C. So if we look at, if you listen, you'll hear it. Okay, the first note it played was this 48. This is left over from the previous time through. So that's the first note that was just played, and that's a note on, followed by a note off. This doesn't tell us the duration that's happening, but it's just not putting that message into the debug. So that gives us the 48, 52, 53, 45, 48, 45, and then the octave jump to 57. So those are the MIDI notes that were being sent, and that's how we're sending them. So let's go back to the full program here. And in fact, before I move on, let's just check if we have any questions. Oh, let's see. There's a good discussion over in the Discord chat about some various strategies, which is great. David G says, why not do index plus 45? That's a really great suggestion. That would allow us to read these indices and not have this second list. And the only reason not to do that is I didn't think of it. But really good idea. I was excited though to be able, I've used this one before, but I don't think I've shown it, to be able to use this find index of block is really cool. Because it allows you to search through a list and find out which number has that item. Okay, so that's what happens when I press A. Now, I mentioned two other things. I've got two songs in here. So the other song I'm actually just defining as song B. So remember in the startup we defined song B, and that is this one here. It's a little bit of a longer melody. And I have the press A and B buttons together. Hold on, I'm going to collapse all the blocks and just open this one. So I have this one set. If I press both A and B at the same time, then we'll get a different song. So yeah, that'll work. So if you listen, I'm going to press these two at the same time. I'm going to move my microphone over there. Let's see if we hear a different song. This one you might recognize. I made up that other one. This one's a famous song from the 80s. All right, it's a bit repetitive, but the song it's the model from Kraftwerk. So hopefully there were some guesses over in the Discord. I probably should have let that simmer before I gave it away, but I was so excited. You'll notice one thing I was doing is when I press these together, MakeCode will naturally not interrupt a operation that's happening inside of one of these button presses until it completes it. You can do different button presses on top of each other, which I'll demonstrate in a moment. But these, if I press it 3 times in a row, it kind of buffers that and it gives us perfect timing. So it'll just play it with the exact interval necessary to loop one after another, which is pretty nice. And in fact, someone mentioned in the chat that you can use CircuitPython to do very similar kinds of things, and there's a lot of power in there. But for me, one thing I've found just in the little bit that I've been using the microbit MakeCode with MIDI is that because MakeCode is threaded, it makes it very easy for me to do things like play a chord, and while it's playing, go ahead and play a melody on top of it, which I struggle with that type of code sometimes inside of CircuitPython. That's my own deficiency, not CircuitPython's. But for me, this is I can get this very easily. I can understand how I can do things at the same time here. And so speaking of that, that's a bit of a segue here. If we go back now and look at, let me minimize this block for a second. If we look at what happens when we press the button A, or rather the button B, I'm going to bring this over. So this one I approached a little differently. If we take a look at the code in here, I'm no longer using that sort of catch-all block. I'm not using this guy that wraps up a whole bunch of stuff at once. And the reason is I believe these will play sequentially. If I put 3 of these on top of each other, it's going to play one note for the duration, and then it's going to move on to the next one, and then it's going to move on to the next one. By using MIDI messages in a more elemental form here, what I can do is I can send 3 notes essentially at the same time. There's going to be a tiny, maybe a fraction of a millisecond delay between these, but it's nothing that I hear. And I'm even toggling on some LEDs, so it's taking a little bit of time to do that as well. But these, in essence, play like a chord. These will play all at the same time when we press note on. And that's because I'm not giving them the duration. I'm just saying turn the note on. I'm specifying some notes here by number. I didn't use my converter there just for no particular reason. I did this first, so this is a remnant of how I worked on this. And then I mentioned that in the startup I have a variable that's a little Boolean true-false toggle. So this variable called held chord, initially I'm setting it to false, which means there's no chord being held. And then I just use that so that I can use the button B like a toggle. The first time we press it, it switches that variable to true for held chord. It plays all the notes. The next time I press it, it will find this condition not to be true. It is on held chord, so that means it's jumping down to the else section, and then it sends the note off message. So this is a little more of an elemental note on, note off as far as MIDI goes, and that's what gives us this held chord. In fact, we'll switch to a different synth here. Let's see, I think this one might hold synthetic voice. So now I'll press, you'll see the B button causes the chord to play, and it's going to also light up some LEDs, and it will stay playing if that synth has a long duration. Okay. Now, one other thing that this gives us the ability to do that's pretty cool is, for one thing, play a chord and then play a melody on top. So let's try that. These don't necessarily go together, but they're not awful. Okay, which is great. I can now lay down some a backing chord or a bass line and then play a melody on top of it. One thing I'm not doing here, and partly it's just because I don't know GarageBand very well, but we can send to different MIDI channels. So the button B could be sending to MIDI channel 2, and that could be played on a, let's say, a big lush pad type of synth. And then we could be sending that melody line to a more lead type of synth on MIDI channel 1. So if your software will support having different instruments on different tracks, then you could send out up to 16 instruments all at once, which is pretty cool. Which also means you could set this up just as sort of a MIDI playback machine. You could have a microbit that just plays different MIDI songs, and if you get everything all set up, it can be your little weird Walkman. The other reason that I wanted to show having a held chord is that I've got one other little trick here to show, which is I mentioned control change. And control change is essentially any knob that you might change on a synthesizer. If we hold a note down or hold the chord down and then start sending a control change in a way we're going to modulate the way that sound, the sort of structure of the sound, the timbre of the sound, the harmonics that you hear in the sound, we can give some sort of movement and motion and life to the sound. I've created a function here that's called LFO. This stands for low frequency oscillator, and it's a typical way of sending some sort of a change in the way that your sound is modulated. And so what I have here, if we look at it, is that I'm sending this MIDI channel 1, that's what this lead keys variable stands for, is getting a control change. So I used this block, this control change, 0 to 0. So what this is asking for is which MIDI channel or which MIDI control change channel are we sending to, and what's the value we're sending to. So the values range from 0 to 127. The different control change channels, here in this example of this MIDI keyboard, I think 7 of these 8 are sending fairly standard MIDI control change. This one has a joystick that goes, I think, up and down for pitch bend and left and right for modulation. So we use modulation. That one's typically wired up to do something interesting on most software and hardware synths. And that is a message that goes out over control change channel 1. So I've got this control change 1, that's the channel. And then I'm sending essentially an ascending and a descending ramp of values. So it's going to go up to 127 and then back down to 0. The rate that it runs is dependent on what I feed it when I call the function. So this will be a pretty fast one. So this is 1 millisecond pause between each step there. So what I'll do is I'll place a forever loop, and it's just going to constantly run let me find it here. Basic, there it is, basic forever. It's going to essentially constantly call that LFO, run through it, run through it, run through it. I think that'll work. And then if we hold a chord down, we should hear that modulation. Now, in order for this to work, I got to upload new code because I didn't have that running. And we'll take a look at what happens in the serial monitor. We should see values streaming pretty much constantly, going 0 to 127 and back down to 0. So that's going to be happening, and then we should also be able to play chords. And I may not have the threading working great here, so it might need to wait for between those LFOs to run before it plays our chords. So we might set it up differently, but let's try this out. So first of all, let's take a look at the... oops, no, quit that. No, don't launch my mail. Where did my... There it is. There's my terminal. So you can see it's now running that LFO, that low frequency oscillator. It's sending a control change to channel 1, and its value is going from 0 to 127 and back down. So that's already happening. In fact, if I just plug in my MIDI keyboard and hold a note, we should hear that. But I'll instead press my B button on here, which will allow it to hold a chord, and I'll move my mic over so that we hear it. So take a listen. We should hear the sound changing over time. Oh, I'm not hearing it at all. All right, let me restart the serial monitor. Why am I not hearing it? What did I do? What have I done? Oh, I've errored this guy out. Right. Let's try that. I had this working, I promise, but I've broken it now. Okay, you know what I'm going to do? I will try plugging in a keyboard so that the microbit will just be sending the control change, and the keyboard will be used to play notes. Let's see how that works. So I'm going to just plug in my little MIDI controller here. And okay, so we should hear. Okay, so what I'll do is stop this monitor so we can hear a before. Okay, I'm going to move the mic over. So listen to the sound of this. I might change to a different synth, but listen to the sound of this. And now I'm going to restart. So that little wow, wow that's going on, that's the modulation that's happening. Just as if I were moving the modulation controller. There's pitch bend. So there's the modulator on the keyboard itself, and that's just happening automatically there. So you can imagine with, let me stop this guy now. So you can imagine that with all of the different types of inputs that you have on a microcontroller like the microbit, and there are a lot of different control CC sort of knobs to send, we can do things like use the accelerometer and just tilt the controller around to send different types of pitch bends or CCs. To be honest, I find pitch bend to be really annoying when you hook it up to things like this, because you want to use pitch bend sparingly, and it just tends to go off all the time if you hook it up to something like an accelerometer. Unless you leave it on the table and then kind of nudge it every once in a while. But a little goes a long way with pitch bend. Things like light sensors, touch sensors, and then you can hook up other external things on there. I believe there's a magnet sensor we can use on the microbit. That might be a fun one. Just as you move the magnetic sensor, you get pitch bends. So that just about covers it. What I'll do before we go is just show the share code for this, and in case anyone wants to use it, there's the QR code. I might need to move this. You can also use that URL there. And that covers it. So that is the basics of MIDI inside of MakeCode using microbit. Hope you enjoyed it. I've had a lot of fun digging into this, and I think there's another MakeCode live stream coming up next on the Microsoft Twitch.tv MS MakeCode channel. So for Microsoft and Adafruit Industries, I'm John Park, and this has been MakeCode Live. I'll see you next week. Bye-bye.